Hi, my name is Dr. Steele, and today we're going to be talking about probability. The curtains, that was cute, right? All right, I just wanted to let you know that this is part of a series, so be sure to check out the other parts. In this video, we're going to go over a definition of probability, talk about complementary events, empirical versus theoretical probability, and types of questions dealing with frequency tables, dice, and tree graphs. So in your book, you might have a fancy smancy kind of definition that doesn't really make too much sense. So I tried to write one that's pretty straight and to the point. So the chance of something happening is determined by dividing the number of ways it can happen by the total number of possible outcomes. Another way you can think of it is the probability is a chance of something happening. And we can write this a variety of ways. One way is number of desired events over total number of events. We can say number of outcomes over the sample space. We can say the result of the experiment over all possible outcomes. Either way, same thing. Now, when dealing with probability, we have a scale from 0 to 1, or you can think of it as 0% to 100%, where if you have 0, it's nothing, it's definitely not going to happen. If you have 0.5 or 5/10 or 50%, then there's an equal chance of it happening that there is of it not happening. And then if you have 1 or 100%, it is definitely going to happen. And watch to the end of this video because one of my favorite chance clips I had to put in there, but you gotta watch to the end. So let's look at an example. In a bag, there are 3 yellow, 4 green, and 2 blue marbles. What is the probability of choosing a green marble? All right, so in the picture, we can see that there are 4 green marbles, also in the question. And then we want to count the total number of possible outcomes. And so there are 3 yellow, 4 green, and 2 blue for a total of 9 possible. So the probability of drawing a green is going to be 4 out of 9. Another thing that's dealing with probability are complementary events. And an easy way to think about it is dealing with something that you do every day. Yes, you do math every day. I know, right? Go figure. If there is a chance of 40% it is going to rain tomorrow, what is the chance that it will not rain? Yes, you can answer. Right, 60%. Again, you probably just knew that, but kind of what was going on in the back of your mind was you know that we have a 100% probability period, right? And so if there's a chance that 40% that it is going to rain tomorrow, to figure out the chance that it's not going to rain, you're going to do 100% minus 40% for 60%. Now, another way we can write this, you want to recall that 100 is the same as 1, 40% is the same as 0.4, 60% is the same as 0.6. So 1 minus 0.4 is 0.6 or 6/10. And so we are going to have our complementary event, which basically just says you're going to take 1 minus the event that it is going to happen, or the opposite of what the question is asking. So let's look at the previous example, but let's change the question a little bit. So instead of looking for the probability that we will have a green marble, let's look at the probability of not choosing a green marble. Okay, so recall the probability of choosing a green marble is 4/9. So if we use a rule that we just learned, the probability of not choosing a green marble is going to be 1 minus the probability of choosing a green marble, which is 4/9, and that is going to give us 5/9. Now, hopefully you are able to enter fractions in your calculator if you're allowed to use a calculator. So you can just enter 1 minus 4/9. If you're not, recall that 1 is the same as 9/9 or any number over itself if you have to change the whole number into a fraction so that you can subtract the two. Now let's talk about empirical versus theoretical probability. We have a die that is rolled 300 times in an experiment. What is the theoretical probability for an even number? Another way to say this is, in theory, if I roll a die 300 times, what do I expect to happen? Well, I expect that half of them are going to be even, which would be 150. And so 50% or 5/10 are going to be an even number. That's in theory. Now, when we look at what is the empirical probability for an even number, that is if I actually took the die and rolled it 300 times. No, I did not do this. What actually happened? So if we look at our table, we have our even number 2, we have 45 times. Our even number 4, 57 times. And our even number 6, 45 times. And again, it's still out of 300 rolls. And so when we add those all together, we get 147. And if we write that as a decimal, it's going to be 49 hundredths. So again, theoretical in theory, empirical what actually happens when you do the experiment. Let's look at frequency tables. What is the probability of selecting a worker aged 18 to 25 to the nearest hundredth? We go to our table, we have 18 and 25, and so we have a total of 125 over the total amount of workers, 775, and that is going to give us a probability of 16 hundredths. Let's look at another frequency table. What is the probability that a randomly selected 45-year-old is a male? So for this one, we're only looking at 45 or older. So we're only looking at this column here, right? And so we have 125 males out of a total of 225 that are 45 or above. Now, sometimes you might be asked to give a fraction. Sometimes you might be asked to write it as a decimal. Sometimes as a percentage. And so make sure that you are paying attention to what the question is asking you to write it as. If it's asking you to write it as a fraction, make sure you simplify. Again, typically most calculators, if you put in 125 over 225 and hit enter, it will give you the simplified number. And again, sometimes you have to write it as a decimal. And if you have to do that, you're just going to do 5 divided by 9, and that will give you 56 hundredths. Now let's look at some questions that involve dice. When 2 dice are rolled, what is the probability that their combined total is 8? And so you could try to kind of figure this out on your own, or you can make a table. And so the way the table is made, I'm going to have the representation of 1 die, the numbers that are possible, going horizontal, and then 1 going vertical. And then I'm going to put the sum in a nice little table. Okay, so for instance, 1 plus 1 gives me 2. 2 plus 1 gives me 3. And 1 plus 2 gives me 3. And so that's how I'm going to get all of these numbers. And again, you don't have to do all of them. You can just do the ones that it's asked, but it's a good way to make sure that you get all of whatever the question is asking for. And so for this question, we're looking for their combined total is 8. Those are the ones where if we add, we're going to get 8, and there's a total of 5 of those. Now, we need to put it over the entire amount of possibilities. So you can sit here and count all of these, or you can remember that if we do 6 times 6, we're also going to be able to get the number that are possible, which is 36. And that is simplified. Now, let's think about this question. 2 friends pick a card from a deck numbered 1 to 6. They then add the numbers on their cards together. What is the probability that the sum of the numbers on their cards is less than or equal to 9? Now you might say this is kind of similar because I'm finding the sums, but I'm not actually rolling dice. So can I do it the same way? Yes, you can. Instead of dice, I'm just going to have cards numbered 1 through 6. Again, one going horizontal and one going vertical. Then I'm going to fill in this pretty chart. Now, if we think about it, the sum of the numbers on their cards is less than or equal to 9. So numbers that are less than or equal to 9 are going to be here, and that's quite a bit. So instead, I'm going to do the numbers that are greater than 9. So we're going to have 10, 11, and 12. And so we have 6 out of, again, 6 times 6 for 36. Again, that are greater than 9, but that's not what the question is asking. So what can we do to find what the question is actually asking? We did it before in this video. Can you remember the vocabulary word? Think about it. Did you say complementary event? If you did, good job, that's correct. Okay, so we're going to do 1 minus, again, what the question is not asking for, which is 6 over 36. And our final answer is 5, 6. And again, you don't have to do it this way. You could count all the ones that are in teal, or you can do it this way. Either way is perfectly fine. Now let's look at tree graphs. If a coin is flipped 3 times, what is the probability of getting exactly 2 heads? We can think about it this way. On the first flip, we can either get heads or tails. And then to find out some of the possibilities for the second flip, I'm going to take each one of those and break it up into heads and tails again. So this is saying the first flip is heads, the second flip is heads. And then we have the first flip is heads, second flip is tails. Then we're going to do the same thing, but starting with tails first. Now, again, we're doing it 3 times, so I'm going to do the process one more time. And so I'm going to have heads, heads, heads for one of my possibilities. So again, I'm going to break this up into heads, tails, this into heads, tails, and the same down here. Now let's write all the possible outcomes. So another one would be heads, heads, tails, heads, tails, heads, heads, tails, 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 heads, heads, tails, heads, tails. All right, you should get the hang of this. So what is the next one going to be? Don't just stare at the camera. Oh wait, that's me. Don't just stare at the video. Answer the questions. I'm trying to help you here. Yes, the next one would be tails, tails, heads, and the last one is tails, tails, tails. So those are all of our possibilities. So we have 8 total possibilities. Now we want to go and see exactly what they are asking. So we want to know the probability of getting exactly 2 heads. And pay attention to this because sometimes they'll say at least 2 heads, which might give you a different answer. Okay, so exactly 2 heads. We have 2 heads here, 2 heads here, and 2 heads here, for a total of 3 out of 8 possibilities. In a local college club, members flip a coin 3 times to decide whether to have a game day or a movie marathon. What is the probability that they will choose to have a game day every time? All right, so notice that we have 2 options, right? Game day or movie, and we want to see it how many times, right? So we want to see it happen 3 times. So you have 2 of something, multiple times, do a tree. So one option is game night, and then we can have a movie. And again, we're flipping this coin 3 times, so we're going to do the same thing again. And so one possibility will be game night, game night, movie night. Movie night, game night, movie night, movie night. And we're doing it 3 times, so we're going to have to break these up one more time. All right, so now let's write out all of our possibilities. So we have game, 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 movie, game, movie, game, 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 oh, game, movie, movie. I can read, I promise. And we also have movie, game, game, movie, game, movie, MGM, movie, movie, game, movie, movie, movie. Okay, so let's see what the question is asking. They will have a game day every time. So this is the only time they have all game days, which is going to give us 1 out of a total of 8. Joel's Pizza is located in Wichita. Joel specializes in California-style pizza, and it offers the following. So for crust, we have gluten-free or sourdough. I don't think I've ever had sourdough pizza crust. Anyway, sauces, we have spicy tomato, tomato barbecue, and sizes, we have medium and large. Determine the sample space for the kinds of pizza that can be ordered. Now, this is different from the tree graph we did before, but we can still do a tree graph. So one possibility for crust is gluten-free or sourdough. And then we can break each one of these up to represent the different sauces. So this is saying you can have a gluten-free with the spicy tomato, gluten-free with tomato, gluten-free with barbecue, right? And then the same thing with our sourdough crust. And then we're going to break each of these into the possible sizes. And so this would say gluten-free, spicy tomato, medium, gluten-free, spicy tomato, large. And we're going to do that for the rest of them. And then we're going to write out all of our possibilities. No, I'm not going to read those. And so we want to determine the sample space for the kinds of pizza that can be ordered. Notice it says determine the sample space. Remember, the sample space is basically how many different types of possibilities there are. And so if we count, there are 12 total. Now I'm going to hip you to something kind of new called the fundamental counting principle, which is another way we can solve this problem. So fundamental counting principle, basically I'm going to put how many options I have for each possibility and then multiply them. So for example, for crust, I have 2 possibilities. Multiply that by, for sauces, I have 3 possibilities. And for sizes, I have 2 possibilities. And guess what? If we multiply all that together, it's also going to equal 12. And so that is the fundamental counting principle. So for this question, you could have done it a couple of different ways. Now, don't tell anyone, but I'm going to put you hip to something. It's kind of a secret, but I'm going to tell you because I like you. We're going to do a tree graph with no tree. How, you ask? Let me tell you. What is the probability of guessing at least 2 correct answers on a 3-question true or false quiz? Well, from our previous slide, we know the fundamental counting principle tells me that I can write how many possibilities, multiply them together to see the sample space. And so I have one question that can be true or false, so that's 2. Another question that can be true or false, and another question that can be true or false. So we can write it as 2 times 2 times 2, or 2 to the 3rd power, which gives us a total of 8 possibilities. Now here's the cool part. I'm going to take 8 and divide it in 2, which is 4, right? So I'm going to write 4 correct answers and 4 wrong answers. And then half of 4 is 2. So I'm going to write 2 correct answers, 2 wrong answers. 2 correct, 2 wrong. Half of 2 is 1. So I'm going to write 1 correct, 1 wrong, 1 correct, 1 wrong, correct, wrong, correct, and wrong. Now, if you compare this to the tree graph and to our possibilities, these are exactly the same thing that you find at the end of the tree. You are welcome. Now, to answer the question, what is the probability of guessing at least 2 correct answers? So, at least 2, 3 is counted. Make sure you read the question. So that's one possibility, 2, 3, and 4. So we have 4 out of a total of 8, which simplifies to 1/2. Thank you so much for joining me. Please don't forget to like and subscribe. And if you want to follow me on any social media, there is my handle and here is my website. Now, I just want to remind you that mindset is very important. So whether you think you can or can't, you're right. And no, I didn't forget about that video that I said I was going to play. And so here it goes.
What do you think the chances are of a guy like you and a girl like me ending up together?
Well, Lloyd, that's difficult to say, and we really don't...
Hit me with it! Just give it to me straight. I came a long way just to see you married. Just, least you can do is level with me. What are my chances?
Not good.
You mean not good like 1 out of 100?
I'd say more like 1 out of 1,000,000.
So you're telling me there's a chance?